Okay, we are going to continue to talk about key features of rational functions. The other day we talked about vertical asymptotes and the POD. So now we are going to continue talking about two other types of asymptotes. And the first one we'll talk about is called a horizontal asymptote. And a horizontal asymptote has to go horizontally, which means it must go through the y-axis. So when you are writing your final answer for that one, it will look like y equals a number. And the second one we will talk about is called a slant asymptote. And a slant will be a slanted line, which a slanted line is also known as a diagonal line. And diagonal lines will look like y equals mx plus b. And so you'll notice there that we have an example of a horizontal line, and we have for the horizontal asymptote, and we have an example of a diagonal line there for the slant asymptote. So how are you going to know which rational function has a horizontal, which one has a slant? Well, let's go to the part that's right below the graphs. And it says in order to determine this, you must look at the degree. And remember, the degree is the highest exponent. Okay, so if you don't remember, degree is the highest exponent. And what we're going to do is we're going to compare the degree on the top, the numerator, and we're going to compare it to the degree on the bottom of the fraction, which is the denominator. So if we're comparing the highest exponent on top and bottom, then there are three situations that can happen. So down below, there's an A, B, and C. So A says, well, if you're comparing the exponents, what if it is bottom heavy? So bottom heavy would essentially be saying that the top degree is smaller than the bottom degree. So for example, if I said, I'm not going to give you the big, long, entire rational function. I'm just going to focus on the very first term. But if I gave you something that looked like this, if I said x squared over x to the fourth, okay, then you would say, oh, well, okay, the highest exponent on top is 2. The highest exponent on the bottom is 4. And then you would be like, oh, this one is bottom heavy because the exponent on the bottom is bigger than the one on the top. And if the exponent on the bottom is bigger, then it is horizontal. So I do have HA written right here. So HA is for horizontal. So it is a horizontal one. And then the good news is that it is always, always, always going to give you the answer of y equals 0. So there's not even any calculations, any kind of work, anything you have to do to it. You just be like, oh, if it's bottom heavy, it's an HA, and it's always going to be 0. Okay, the second one that can happen, second case, is when you compare the degrees, the highest exponents, and they happen to be identical on top and bottom. So that's what we call equal. So if they're the same, if they are equal, okay, it's still going to be an HA. But this one says it's not going to just be y equals 0. It says it's going to be y equals the leading coefficient over the leading coefficient. So for this one, if I had 6x to the third over 5x to the third, then you would be like, okay, what's the exponent on top? 3. What's the exponent on bottom? 3. Oh, they're equal, they're the same, so I know it's going to be HA. And now leading coefficient means what is the number in front of x to the third. So what is the number in front of x to the third on top? 6. What is the number in front of x to the third on the bottom? 5. So then your answer would be y equals 6 over 5. Because it's the coefficient in front of the x on top over the coefficient of the x in front of the x on the bottom. Boom. Okay, so there's two ways you can come up with a horizontal asymptote. It's got to be bottom heavy or equal. So then the last one is the slant asymptote, and there's only one way you can come up with a slant, and that is if it is top heavy. So top heavy means that the numerator is greater than the denominator, and that's going to give you a slant. And remember, the slant is always going to be y equals mx plus b. And you're going to use synthetic division to help you get this one. And synthetic division is something we used in our last unit. And then as we're working out a problem down below, then I'll show you how we use synthetic division and such to get the answer. So let's just jump into some examples. Okay, so on the first one, if I have just x on the top, then that would be x to the first power. So I'll just put a little power of 1 if there's not a power there. On the bottom, the highest exponent is 2. So if you compare the two exponents, are you okay? Sorry, that was my dog barking. She's just a little excited. Are you okay with saying it is bottom heavy, where the bottom is bigger than the top? So just for your reference, you don't have to write this down, but I'm just going to put it there so that everybody knows what I'm saying, that it's bottom heavy. Okay, and if it's bottom heavy, so then if you look up above, bottom heavy is always an HA. And then that one is always y equals 0. So that one you didn't even have to do any other kind of work. You have your answer and you're done. So if I move on to the next one, for this one, compare your exponents. So on top we have a 2. On the bottom, if there's not an exponent, that's a 1. So this time the top is bigger than the bottom. So for your reference, this one is top heavy. And if it's top heavy, then that means it is a slant. And for slant, this is the one where we said you have to do synthetic division. So for your synthetic division, okay, you're going to start with what's on the bottom. So on the bottom I have x minus 2. You're going to pretend like you solve that for x, and you're going to get x equals 2. And that's going to be the number that you put into the little corner box. And then the numbers that you put off to the side, those are going to be the coefficients that come from the top of your fraction. So if you look on the top, in front of x squared is a 1. In front of x is a 3. And your plain number is a 2. So those numbers come from the top. Drop your first term and then multiply. And now add. And then multiply. And then add. And then remember, slant needs to look like y equals mx plus b. So your first number is your mx. Your second number is your b. And then the 12 is your remainder, and we do not use the remainder in our equation, so technically you can just cross that one out. So So then when you're writing your answer for this one, you're just going to go y equals 1x, or just x, plus 5, because 5 was our b. And that's it. That's your answer. Then if you go to the third one, if you compare your degrees, your exponents, you're going to notice you have a 2 on top and a 2 on the bottom, and those are identical. So this one is equal. And if they are equal, that is HA. And if it's HA, then you have to go, when it's equal, you have to go coefficient over coefficient. So what's in front of x squared on the top? And that is a 3. And then what is in front of x squared on the bottom? Well, if there's not anything listed in front, then that means it's a 1. So then you would have y equals 3 over 1, which is just y equals 3. And then you're done. Okay, if you go to the next one, okay, on 4, your degree, highest exponent on top is 2. On the bottom it is 1. So this one is top heavy, which top heavy is a slant. And slant, you have to do synthetic division. And so remember, you're going to look at the bottom and you're going to solve that for x, and that's going to give you your number you put in the corner box. And then you're going to list your coefficients from the top. And then you're going to drop your first term, multiply, and then you're going to add. And then remember, we don't really care about the remainder anyway, so I'm just going to cross off the last one. And then this is mx, and this is b. So y equals 2x plus 13 is your answer. On 5. Okay, on this one, the highest exponent on top is 1. And then the highest exponent on bottom is 2. So then you have 1 over 2. So this one is bottom heavy. And if it's bottom heavy, that's HA. And then if it's HA, you're going to go and say, oh, well, that's going to be the one that has no work, so y equals 0. Okay, on the next one, the exponents are equal on top and bottom. They're both 2. They're both the same. And so if they're equal, then it's going to be an HA. And then you're going to be like, oh, well, if they're equal, this is the one where you have to go coefficient over coefficient. So in front of each x squared, you would have a 1. So that would be 1 over 1. So y equals 1. Now, I've also had some people, just going to throw this out there, that have in the past said, okay, well, what if I went ahead and found my VA first, like we did in the last lesson? So what if I went ahead and said, I factored in GCF my fraction. So if I took out a GCF on the top and I had x, parentheses, x plus 8, and then I fast factored the bottom into x plus 8 and then x minus 1, and then I was like, oh, hey, look here, x minus 8 cancels out and I have x over x minus 1. If I use the simplified form of the rational expression, would I still get the same answer for either the horizontal or the slant? Okay, so let's test that theory. Would you or would you not? So this one, I would be like, oh, look, the exponent on top is now a 1. The exponent on bottom is now a 1. Those are still equal, and the leading coefficient is still a 1 over 1. So yes, you would still come up with the same answer. So even if you're using the simplified version, you would still come up with the same answer for the horizontal one. The only one I don't suggest you using the simplified version on is the one where you have to do slant, which would be coming up here in a second, and I could explain that one to you on the reason why. So hang on. So for this one, you would say, oh, exponent is 2, the exponent on the bottom is 1. So for this one, it is top heavy. And if it is top heavy, then that one is a slant. Okay, and then in the box, you would look at the bottom, and basically you're just switching the sign. So you would have 4. And here's the reason why I don't want to use the simplified version, because if you took an x out as a GCF, and then you had x parentheses x plus 2, this is too hard to get your coefficients for the top, for the row up here. So that's why on the slant, I would never suggest using the simplified version. I would always just use the original problem, because then that way it's much easier for you to get the coefficients to list out as 1, 2, and then there is no plane number, which is 0. So drop, multiply, and then add, and then we don't care about the remainder. So there's my mx and b. So y equals x plus 6. Done. Okay, the last two, if you want, you can pause the video and try them yourselves and then see if you get them right. Or if not, you can just let the video play and write it down. So for this one, I noticed that it is equal. And if it's equal, then that means it's HA. And if they're equal, you want to do coefficient over coefficient. So that would be a 1 over 4. So then my answer would be HA, y equals 1/4. On the bottom one, there is no x on the top. So if there is no x on the top, then I'm just going to think of that as x to the 0 power, because there is no x there. So 0 is smaller than the power of 2, so this one is bottom heavy. Or if you just want to be like, oh, there's no x on the top and there's an x on the bottom, it's got to be bottom heavy, that's fine too. And if it's bottom heavy, then it's HA, and that one is always 0. Done.